Earth science time. We're talking about wind. Levi, don't mock me. Wind erosion. Wind erosion today. Let's put this. Okay, wind erosion. What's the fancy name? What's the fancy name?
Aeolian.
Aeolian. Yeah, we sometimes call this Aeolian erosion. So, unlike the types of erosion we have talked about so far specifically, this one is powered by a different energy source. And what is that energy source? Driven by, well, what causes the wind? Driven by the wind, which is caused by...
Change in temperature.
Yeah. Which is caused by really change in pressure, but that is caused by change in temperature. So, caused by differences in pressure. Okay, and so this is something that your entire life, someone, I don't know, your grandpa or someone has told you, water, and you know this, water does what when it flows? Downhill, right? Everyone is always saying water. That's not strictly true. What water does and what air does, all fluids flow from high pressure to low pressure. That's just what they do.
So you can have a stream.
This is different from the kind of pressure that we talk about in physics. This is something called head pressure. But basically, fluids always flow from high pressure to low pressure. So when it's windy outside, whatever direction the wind is blowing, it's higher pressure where it's coming from. So like you're standing here, this is what you look like, and the wind is coming from this direction. Somewhere over here is high pressure, and somewhere over here is low pressure, and the wind is trying to get from one to another. Think about it like a balloon. Inside the balloon, there's higher pressure than outside the balloon. And so when you let the balloon go, the wind all blows out of the balloon. I'm making this gesture because that's what the little nozzle of the balloon does, right? It makes the farting noise. But it's going from high pressure inside the balloon. This is kind of like, so in real life there's not a balloon in that area, but high pressure inside the balloon to low pressure outside. That's how fluids always move. Anyway, this, on Earth's surface, this high pressure would be caused by some kind of heating because of the sun, and this kind of low pressure, the same thing. It's effectively driven by the sun. So, differences in pressure, which then is caused by differential heating. Okay, I'm going to erase my crappy little drawing. Okay. So, whereas mass movements, we said, were driven by what?
Gravity.
Gravity. Does gravity have nothing to do with wind, though?
No, it does.
No, it does. Yeah, gravity still has to do with this. Gravity affects it by doing what? Gravity, specifically with the sediments. What's the gravity going to contribute?
Doing the sediments get pulled down.
And what do we call it when the sediments drop? We call that the sediments have been deposited. Gravity causes deposition. So basically, if you imagine that you're a sediment, this is you're a sediment, look how happy you are to be a sediment, and you're being carried, you're being upborne by the wind, right? You're on the wind right now. It's kind of a little struggle between gravity trying to pull you down and the wind is holding you up, right? And so if you and your friend, who's a little bit smaller, are both being carried by the wind, and the wind slows down a little bit, who's going to fall first? You first, right? And this is something we talked about in all kinds of erosion, but when the erosional medium slows down, the heavy sediments are dropped first, and then the light sediments, right? This process here, so let me talk about first the reverse of this. If y'all are both hanging out on the ground and the wind picks up, who's going to be picked up first?
The little guy.
The little guy, right? There's a little bit of wind. The little guy's going to move first. And because of this, there's a process called deflation, which, well, we already talked about a balloon once, but this is a different kind of deflation. Deflation in the geological sense is where, because this has happened for a long period of time, an area has only what kind of sediments? This guy, he flies away. So what kind of sediments are left? Just big ones, right? Deflation is where small sediments are carried away, leaving large ones. And when I say large sediments, what size of sediments are that? Are those? Yeah, probably pebbles. Maybe same, depending on the average wind speed.
So concrete used to have a side.
Yes. Okay, so meanwhile, you got this written down now? Okay, so imagine, now I'm going to change my drawing again. So the wind's carrying, I'm using you as an example. You know what you are in this example, right? You're a what?
Sediment.
Yeah, piece of sediment. You're a chunk of sediment. What size of sediment? Maybe.
Pebble or
It tell me the truth, right? It might be pebble, might be sand, but it depends on what.
The amount of force the wind has.
Yeah, the speed of the wind, right? So faster wind can carry faster sediment. What size of sediment is probably the largest that can commonly be carried by the wind? Probably sand. It'd be really strong wind that could carry pebbles. So sand and down, right? We call it sand, silt, and we call clay-sized particles dust when they're carried by the wind, and in some other circumstances. But if you see dust on your test, that means clay-sized, maybe silt-sized, but that dust is not like a true sedimentology word, but you might see it. So we'll say sand here. We'll say it's a facetal wind is carrying. I don't know why I'm drawing smiley faces on my sediments today, but it's nice. Okay, so you and your friends, you and the homies are going to be blown on the wind, right? And over here is a brick.
Oh, that's nice.
That's nice. Okay, so what's going to happen?
You're gonna run into a brick.
You're going to run into the brick. And if you weren't here, if the wind was completely empty of sediment, what would happen when the wind runs into the brick?
The brick would go wee.
No. If the brick is stuck to something, right? The brick is in a wall, like that song. But what's going to happen if the wind just hits the brick?
It'll bounce off.
Yeah, the wind will bounce. So basically nothing. The wind will either go around or bounce off the brick. But when you and the homies are being carried by the wind now, every single one of you is going to bake a little chunk in this, right? So this is an important thing about Aeolian erosion, is that really it's not the wind itself that causes erosion, that causes weathering of surfaces. It's really the sediments that are carried by the wind.
It's the home.
Right, and we call this abrasion. And you know the word abrasion, right? If you get an abrasion on your body, like it's like a scrape, or like a raspberry, like if you ever, I don't know, fall out of a wagon that's moving and you get dragged along on the pavement, right? That kind of wound is called an abrasion. Abrasion is also what we call it when you like sand down a table. You're doing abrasion. So in the geological sense, it's when the sediments carried by an erosional medium, the sediments that are carried by it are knocking pieces off of another sediment.
Can you write that down?
Yeah, abrasion is when sediments carried by this is going to be real messy. Let me just erase. Bye, homies. Sediments carried by an erosional medium, whether other rock. So in like industrial science, this would be like sandblasting, right? That's what sandblasting does. Is it knocks pieces off of something
So
using
it's a type
wind.
of weathering?
It's a type of weathering. It can cause erosion, right? But weathering is the breakdown of this, and then as the sediments get moved away, that's erosion.
Dynamite?
Dynamite. No, that's a whole different thing.
That makes an abrasion pump.
Uh,
Pretty big one.
Small sediments are carried away.
it says sediments carried by, this one says small sediments are carried away, leaving large ones. That's deflation. You saw in the video we watched some of the features that are formed by an Aeolian erosional environment. What were some of the ones in the video? Are you done with this little thing over here now? Yeah?
The little toads.
Yeah, we had, in the video they were yardings, and they looked like this, right? I'm going to talk about it again here, like the lady did. So why are they thinner in the middle? Do you remember what she said?
Because that's where the
Because
sediment
that's where
is
like the
picked
wind
up
picks
and
up the wind.
Right, that's right. So there's like this sweet spot right here where if it gets up here, it's too high. The larger size, the sand and silt size sediments can't be carried this high.
It's a happy medium.
Yeah, exactly. And then down here, there's too much friction with the ground. And so right about here is where the Aeolian erosion is the strongest, and so you get this, I think she said beautiful hourglass shape, right? Another thing that we commonly see is an arch okay, so this is not a very good arch like you might see. There's a picture that you can look at that's better than what I drew. But if this same thing happens, except instead of a lump of rock, there was a rock with a crack in it, eventually that crack gets more erosion. Rock with a crack. Eventually, that crack, in the same way that rill and gully erosion happened, like one water droplet flows down a hill and another follows that same path and it makes that particular path deeper. The sediments can dig this out and make this crack bigger and bigger and bigger until eventually it's a hole. And then when it gets big enough, it's this arch.
Wow.
Arch. I think your book also talks about pillars, which would be like this with the lid taken off it as a pillar. But arches and pillars and the yardings and the toadstools at Toadstool Park, all these things are called ventifacts. Ventifacts. So all the like landscape features formed by Aeolian erosion are called ventifacts. This comes from the Latin word venti, meaning wind, and facts, like artifacts, like things that exist because of the wind.
What was the other one called?
A yarding. I'll write it here for you. Yarding. Yeah, don't say it. But so the ventifacts specifically are formed by wind erosion. Can you think of a landscape feature that's formed by wind deposition? So what would be formed? So first of all, what would a wind deposit look like? What kind of sediments would we find in it? Probably sand, maybe smaller sized particles in sand. But what would a wind deposit look like? Use that table for my coffee table. A dune, yeah. You good on this? Can I erase all this stuff, or are you still? Erase it. Okay. Does anyone object? Levi, you said both erase it and no one objects, but I guess I'll take that as the truth. So all this was Aeolian erosion. Now we're going to talk about Aeolian deposition. Real quick, remind me, in general, when are sediments deposited?
When the wind slows down.
Yeah, when the erosional medium slows down in general. In this case, of course, there's going to be when the wind slows down. And the primary feature we get with these, there are ripples, which are just kind of miniature versions, but then we also get dunes. So here's, in cross-section, a sand dune. And they usually have this shape that is steeper on one side than the other. In this case, the wind is blowing in this direction. So, because I drew the dune this side, I'm just going to draw sediments without faces this time. But as the sand is carried by the wind, what's going to happen? First of all, it's happening all along on the ground. But what's going to happen when this starts to run into this slope here?
It's kind of like deposit.
Right, yeah, the wind is going to slow down because there's going to be more friction, and these are going to be deposited. So this side is going to be doing what all the time?
Building.
Yeah, building up. It's going to be moving like this, right? The dune is, we call this dune migration. And then some of the particles, though, will make it over, and they slow down here because there's an eddy right here. You know what an eddy is? Like a little spiral movement of fluid. And so the wind always slows down on this side. And that makes these sediments get deposited as well, but down here. And so that's why this side is steep, because they get deposited on this side, and then when they come over, whatever ones do come over, just kind of drop. And so this side is really steep. We call this side, the one that's facing the wind, we've already talked about this once, but the side facing the wind is called windward side. And this side is called the leeward side. This is the general truth about dunes. There are a lot, well, your book mentions 4 types of dunes. I don't require you to know the different types of dunes. It's kind of interesting to read about them. It says on page 205 if you want to look at it. But you are not required to know the different types of dunes and how they form. But you are required to know how dunes form and exist in general, and how they migrate, right? They migrate because this side's always getting built up, and this side, I wouldn't necessarily say it's getting removed, but like this side, as this side gets built up, this is slower and slower, and so it does travel that way. So dunes over time travel across the desert. And the last type of Aeolian deposition that we talk about is lus. The word looks like you're going to pronounce it loess. Don't pronounce it loess. The word is pronounced lus. It's German. You don't have to put the umlaut on it like I did, but lus. It's a. You know very much about how to pronounce words. It's a schwa e in the middle, so it's not lus. It's lus. Anyway, doesn't matter. This is what it looks like. Lus would be better than loess. So say it however you want, but don't say lois. That's a lady's name. So lus is dust-sized sediment, which we said could be either very small silt or clay. We don't call it either one of those because clay specifically has to be flat, where this doesn't. But it's dust-sized sediment carried over large distances. And an example of this, an example of this is that, like we saw in the video with the Sahara, where the Sahara Desert blows all across what? All the way across
Africa.
Yes, and then
Into the ocean.
into the ocean, right? All the way to where?
Guatemala.
Maybe specifically Guatemala, but all the way over to North and South America, right? In fact, we said that a lot of the fertility that exists in the Amazon is because of lust. They didn't use that word, but lust blown from the Sahara Desert, the Sahara Desert. Right? We sometimes want to be fancy, but lust is this small-sized sediment that can be blown large distances. It's actually very fertile because remember we talked about soil. The thing we wanted was the loam, right? That had kind of a mixture of clay and sand and silt. This provides the silt part of that, right? Because it's usually small silt-sized sediments. And we have one other thing. Yes, we have one other thing to talk about. Let's go back. You and the homies were riding on the wind, right? You remember that?
How we died because we hit a brick
Well,
wall.
no, sand doesn't die. It just hit a brick wall.
So we died.
There are three ways. Imagine, okay, so there's a particular wind speed here, right? And it's just like in real life. Some of the homies are bigger than others, right? So we'll say this is a pebble-sized homie. Here's a sand-sized homie. Here's a little baby silt-sized homie. And here's your dog, and it's just clay. Okay, so for a given wind speed, how do you think these are going to move differently? Which one can probably move the highest?
The little clay.
The little clay. Can go way up high. What's the silt probably going to be able to do?
3/4 of that.
Okay, maybe not exactly 3/4, but less than this, right? Less than that.
So like 3/4 of it.
Oh, that's bad.
That's half.
Okay. And then the sand, less or more. I mean, this is fairly
Less.
straightforward. And then this
Less.
maybe doesn't even get it off the ground, but could it still move even if it doesn't get off the ground?
Yeah.
It could roll.
They just roll on.
So the point is that maybe these two in the middle we could call the same thing, but if it stays in the air for a long time, we call it suspension. And we'll talk about this again. This goes for all kinds of erosional media. When it stays in that medium for a long time without landing, that's called suspension. What are these two probably going to do? The silt might be suspended for a while, but what are they eventually going to do?
Falling out.
Yeah, and so they kind of bounce. Both the sand and the silt probably kind of bounce. Right? And then they bounce again. And we call this saltation. Have you ever heard anything like the word saltation? Have you heard the word sauté?
I've heard the word salt.
What do you do when you're sautéing something? What's that?
You like flip it.
Yeah. So ideally, right, when we say sauté, sometimes in cooking, we just mean like make the onions brown on the pan. But sauté in French means you're like flipping the pan like that to make them go up in the air. The French word sauté means to jump. That's what you're supposed to be doing, jumping the onions. And this is what this is doing. This is related to that. These jump and then land, and then jump and then land. Saltation. And then this big old chunk of a homie, he's doing what? Rolling. So, and this, like I said, we'll talk about this again when we talk about aquatic erosion, like river erosion, channel erosion, that kind of thing. But for many erosional media, these are the kind of, options. Different size sediment for a given speed will do that. So in very fast wind, pebbles might roll. But usually, like outside, it's not even very windy right now, maybe somewhere, the clay might get picked up, or the clay size sediment might get picked up, and the silt might just be rolling, right? So as it slows down, these ones do different activities. Do you have questions about any of this? Questions about Aeolian erosion and deposition in general?
No, sir.
Anyone? Okay.
Sir.
Bye.